So unit 3 in digital image processing technique is the image enhancement. First, what is mean by image enhancement? So image enhancement is the process of making the images more useful than the original image. So which is used to improve the quality of the image. So for that purpose, we are using image enhancement techniques. Several kind of image enhancement techniques and algorithms are available to improve the quality of the image. So the final outcome of image enhancement techniques or process, it makes the image become more useful than the original image. So what are the features in image enhancement? One is gray level and the contrast manipulation and removing the noises from the image. So after that only we can get the clear image, and edge crisping and sharpening, um, then filtering, pseudo coloring, then making images more visually appealing. So these are all the features which is helpful for making an image in a clear manner. So image enhancement is the process of manipulating an image so that the result is more suitable than the original image for a specific applications. So in image enhancement, two categories are there. One is spatial domain and another one frequency domain. Um, in the spatial domain techniques, so here the term spatial domain based on direct manipulation of pixels of an image. So in an image, so the pixels are manipulated directly. Um, so here the spatial domain process is denoted by g of x comma y is equal to transfer function of f of x comma y. So here f of x comma y is the input image, g of x comma y is the processed image. Here t is an operator on f defined over a neighborhood of point x comma y. Then defining a neighbor. So how to define? So the neighborhood of point x comma y is defined by using a square or rectangular subimage area centered at x comma y. So here this picture shows the 3 cross 3 neighborhood of x comma y. Then one more concept, histogram processing. So histogram, so in that three different techniques are there: histogram equalization, histogram matching, and local histogram processing. First, histogram means number of occurrences of the pixels in a given image. So that is defined by histogram, number of occurrences of the pixels. So here normalized histogram. So it is obtained by dividing each of its components by the total number of pixels. So here R sub is k represents the kth gray level. Then n sub is k represents number of pixels in the image with that gray level, and n represents total number of pixels in the image. So P of Rk is equal to Nk by n. Here histogram equalization. So first in a dark image represents the pixel intensity values as low intensity. So the pixel gray level ranges from 0 to 255. 0 represents a darkened image and 1 represents a whitened image. Between the dark and white, so here if the pixel intensities are very low value means this is a dark image, and pixel intensities are high, so the image will become brighter. So for that, we are going to equalize the histogram, so which is used to make an image in a bright way. Uh, so this is a low contrast image. I mean the pixel intensity values in uh, very narrow. Between the range is very small in a low contrast image. In a high contrast image, the pixels are distributed equally from 0 to 255. So the second image shows the high contrast image. And so here spatial filtering is the process of moving the filter mask from point to point in an image. So here image origin 3 cross 3, we are using 3 cross same 3 cross 3 mask. So now the mask coefficients are represented in terms of W of 0, 0, 0, 1, 0, minus 1. Likewise, 3 cross 3 neighboring coefficients are represented. Mask coefficients means in terms of W, and original image pixels are represented in terms of function f of x comma y. So here we are using spatial filtering in two ways. One is smoothing and another one sharpening. Smoothing techniques are classified under linear and non-linear manner. In a linear side, we are using two different filters. One is box filter and another one weighted average filter. Non-linear techniques are median filter, max and the minimum filter. Uh, Sharpening. How to sharpening a image under spatial filtering. So first order derivative filter, second order derivative filter, unsharp masking and high boost filterings are used for sharpening process. So first is smoothing by linear filter. So linear spatial filter is simply the average of the pixels contained in the neighborhood of the filter mask. So it is also called as averaging filter. So here two different filtering techniques are there. One is box filter and weighted average filter. So this is the mask for a box filter. So here all the coefficients are equal. Okay, so here 3 cross 3, so totally 9 pixels, so 1 by 9 into all rows and the columns, 3 cross 3 matrix of 1 1 1. And weighted average filter. So here the mask for weighted average filter is 1 to 1, 2 4 2 and 1 to 1. And smoothing by non-linear filters. So it is also called as order statistics filter. So here the values of the pixels covered by the filter mask are ordered, like it is arranged in ascending order from minimum to maximum. So here three different filtering techniques to use for smoothing. One is median filter, max filter and minimum filter. Then this is the mask for second order derivative filters, and here how to obtain the sharpened image, sharpening. So we obtain from f of x comma y minus del squared into f of x comma y, otherwise f of x comma y plus del squared f of x comma y. So if the center coefficient is negative means f of x comma y minus del squared f of x comma y. Del squared f of x comma y is the Laplacian filtered image. It is subtracted from the original image when the center coefficient is negative. Otherwise, Laplacian filtered image is added with the original image if the center coefficient is positive. So this is the way we can able to get the sharpened image.